Okay, so I want to show you guys just a quick little demo about indicators, and then I'm going to show you how to write indicator equations or Bronsted-Lowry equations using indicators in there to kind of help you describe what's happening. Okay, so this is just a carbonate ion solution, so CO3 2 minus. I'm going to add some bromothionyl blue to this, which just means that I'm going to be adding some Bb minus ions to this solution, and then I'm going to add some methyl orange, which just means that I'm going to be adding some MO minus ions to the solution. And as you can see, I've listed up here, Bb minus ions, if you take a look in your data booklet on the indicator chart, the acid-base indicator chart, you can see that Bb minus ions are blue, and you can see that MO minus ions are yellow. And so a mixture of those two present in the solution would show us to have a green solution. Now, if I add some acid to this, it's just hydrochloric acid, so strong acid of just adding straight up hydronium ions to this. Let's see what we can observe as far as color changes. And hopefully you can see this okay on the camera. So I'm adding in the acid, and I'm still green, and then I turn into yellow. And then if I continue to add, then I go a little bit more pinkish, sort of orange color is really what we're shooting for here. And sometimes these colors of these indicators are a little bit off, but anyways, that's the orange that we were hoping to get. So with this, if I write this down, this was kind of the color change that we observed. We saw it go from green to yellow to orange. All right, so that was just like a really rough titration. I didn't use like a barrette or was precise with any measurements or anything like that. But as I was adding the hydronium ions, the acid, to the solution, I was basically rolling through this titration curve at a pretty quick pace. So there's four sort of junctures that I've labeled on this titration curve that we kind of passed. So we've got this buffer region right here and this buffer region right here, and then we've got these two equivalence points that I've marked either with a star and an asterisk. And you can see at each juncture there's a separate reaction that's taking place. So here at the first equivalent, or at the first buffer region, we've got this hydronium ion being added or reacting with the carbonate ion, and we get the hydrogen carbonate ion and water. And so we get this buffer region because we've got a weak acid with its conjugate base in the solution. So that's one thing to point out, something that we've already learned. Once this reaction is finished though, originally when we've got our species listed here present, this is my acid and that's my strongest base. But once this reaction is done and all of the CO3 2 minus has been reacted, that is no longer an option on our species listed. Instead, what's present in the place of it is HCO3 minus. But it turns out that HCO3 minus is not quite as strong of a base as Bb minus is. And so the hydronium ion at this equivalence point is going to choose to react with this Bb minus ion. It reacts with the Bb minus, making HBB and H2O. And as you saw, I only added 1 or 2 drops of each of the indicators, so it doesn't take a lot of acid for that color change to happen. And so eventually, when this reaction is all done right here, the Bb minus ions are now all gone, and all I have is HBB. And if you look in your indicator table, acid-base indicator table in your data booklet, you can see that now the HBB is all gone. Bb minus is all gone. HBB is now what's present. And if you look at that in your chart, you'll notice that the HBB molecule is a yellow color. So I've got now HBB in the solution with MO minus in the solution. Yellow plus yellow just gives me more yellow. And that's why we saw this change from green to yellows, because we observed this reaction happening to completion. Then I continue to add more acid to it. Now we're in this buffer region here where the pH again is not really changing very much. This acid is reacting now with this is no longer the strongest base available. This one is, so now this reaction is occurring. We get it getting, that doesn't have a minus on it, carbonic acid reacting, or also produced with water. And at some point, this reaction now runs to completion. If I continue to add, as I did, more and more acid. And so then I get to this next equivalence point. And so if all of the HCO3 minus is now gone, and all I have left is carbonic acid, now the strongest base available for the hydrogen, the hydronium ions to react with is this MO minus. And so that is this final reaction right here where the hydronium reacts with MO minus to make HMO. And once all of the MO minus is reacted making HMO, then I'm going to have that molecule instead. And if you look in your acid-base indicator chart, you'll see that HMO is a red color. Now this methyl orange that we have is a bit of a pinkish red, so that's why we kind of got this sort of pinkish orange color, but yellow plus red gives us orange, and so that's what we're illustrating here with this demonstration. And so this is all you got to know as it relates to indicators and reactions, including indicators. You just kind of have to be able to sort of keep track of some of these colors and be able to write those reactions out as I've got them here on the board in sequential order. So that's it, guys. Thanks for watching.